I'm going to go over the last lesson of MP1, and that is the lesson 29. This is last lesson of MP1. All right, and the topic is home to work and work to home. All right, so what are we talking about? So let's say Mr. Berry is moving from Mr. Berry is moving from home to work. All right, and immediately move from home to work with velocity v1 is 40 mile per hour, and immediately he return home. Immediately he reversed the direction and he returned home for some reason. Okay, so this is 60 mile per hour. However, as you notice that this is the home and this is the work, so the distance d1 and this would be the d2. So d1 has to be equal to d2, no doubt. d1 has to be equal to d2, so you can call it d. All right, t1, so this is t1 and this is t2. However, t1 is not equal to t2 because the velocity not the same. That's the reason. Okay, now what we want to find is that we want to find the average speed. So average speed is equal to, of course, total distance over total time. Total distance, when we talk about total distance, total time, what are we talking about? We're going to make a t-table and we're going to write speed is equal to d1, and this is d2. So d1 you can call it, of course, d, plus d2, of course, you're going to call it d. t1 and t2, you cannot call it t1, t, no. So t1 plus t2. Now, you know t1 is, of course, distance over velocity, and t2, of course, distance over velocity too. Okay, so what are we talking about? We are talking about velocity 1 is 40, where it comes from here, and velocity 2 is 60. Where does it come from? Of course, here. Now you have t1 here, which is, of course, d plus d is 2d, t1, which is d over 40, and t2, which is d over 60. Now, what can you do? You can multiply top and bottom by 2 and top and bottom by 3, so you have common denominator. So 2d, you have 3d, plus you have 2d over you have 120. Okay, so s is equal to, what do you get? S is equal to, so I'm going to write it down over here. So s is equal to 2d over 5d over 120. All right, so s is equal to 2d times 120 over 5d. dd cancel, 5 goes to 120 24 times, so s is 2 times 24, 48 mile per hour. So this is the average speed we are talking about. Now what are we going to do? We're going to do distance versus time graph and all those things. Now I'm going to give you the distance. The distance is 120. So from home to work is 120 miles. If that is so, then work to home must be 120 miles because of this, and velocity versus time. Now let's see the distance. So what is the distance? What distance are we talking about? Let's see. We are talking about distance 120 because from home to Brooklyn Tech, 120 divided by 40, which is 3. Okay, so it takes, t1 takes 3 hours, right? t2 takes, of course, the distance remains the same. However, you move faster, so it's going to take less amount of time. So t2 must be, of course, 2. Why is 2? Because you're moving faster. Why is more? Because you're moving slower. Simple. So you have total time. Total time is 5 hours. Your whole trip is 5 hours. All right, so the distance, your whole distance, full distance is 240. Why is that? Because round trip is 240, and one way is 120. One way takes 3 hours, round trip takes altogether 5 hours. All right, first 3 hours you move with 40 miles per hour, and final 2 hours you move faster. So you move 60 miles per hour. That's why it's steeper. So you put 5 over here instead of here. It makes more sense because this interval look like 2 and this interval look like 3 units. So make it a little longer so it makes sense over here. Okay, good. This is 120. This is 120. Okay, 120. Okay, so dt is done. Now we're going to do st. So what would be the when you take the derivative, you're not going to take the derivative over here. We're not going to doing it by calculus, but when you do use the calculus, if you take the derivative, this is going to be 40t become 40, right? If you take the derivative, but that's not what we are doing over here. We are doing like type of we cannot use the calculus, so we are doing like intuition. So the slope is 40, so the diagonal line becomes the horizontal line, so it's become of course 40, and then this is steeper, so this is of course horizontal line but little bit above, so this is of course 60. Now this is of course 3 and this is of course 5. Now area under the graph, would be what? This is the area under the graph. Area under the graph would be 40 times 3, 120. Area under the graph would be what? 60 times 5 minus 3, 120. 120 plus 120 is 240. Check. Magic. Physics is magic. All right, now displacement versus time graph. Okay, so first 3 hours. First 3 hours was going on. First 3 hours you move 120 miles, no doubt. So you put that because somewhere here. All right, the next 2 hours. What are you going to do next 2 hours? Next 2 hours you come back home. You come back home next 2 hours. So 5. All right, you come back home. So this is 40, and this is what? Negative 60. All right, familiar to you. So what is the total displacement? Total displacement is 0 because you start at home and you end at home. All right, so now we're going to take the derivative. When we take the derivative of a diagonal line, of course a horizontal line with the slope 40, of course. If you take the derivative of a negative diagonal line, you get of course a horizontal line but a negative horizontal line, of course. So this is your 3 and this is your 5, and this is of course your negative 60. Okay, area under the curve, which is 40 times 3, 120. Of course it was 120 before because this and this is the same thing, but now is the negative reason. Negative reason 5 minus 3 is 2. 2 times of course negative 60, which is of course 120. Positive 120 and negative 120 gives you 0, and that's exactly what we knew all along. All right, so that was what we did today, and that's going to be on the test number 4.